Hello and welcome to an algebra video tutorial learning about solving a word problem using a linear system of inequalities. Alright, so here's the problem. You can work a maximum of 30 hours a week. You need to make $280 in order to cover your expenses. Your office job pays $14 an hour and your babysitting job pays $10 an hour. Write a system of inequalities to represent this situation. What is the least possible number of hours you can work at your office job and still meet the requirements? Okay, so there we go. So we're going to try and use our understanding of linear systems. There's some things going on here that would use an inequality, and we're going to represent this problem algebraically. We're going to use a graph to help answer it. We're going to find what is the least possible number of hours we can work. All right, well, with any word problem, I like to start off by figuring out what I want my variables to be. Again, I can't use algebra until I have a clear idea of what I'm going to be using my algebra with. So what is changing in this problem? Let's find that question that we have to answer. We're asked to find what is the least possible number of hours that you can work at your office job. So I'm going to make X the number of hours at office job, keeping track of how much I work there. Well, if X is the number of hours at the office, the other thing that kind of varies is the number of hours that I spend babysitting. So I'm going to define my Y value as the number of hours babysitting. Those are the two variables that affect how much I work. So I can increase or decrease the number of hours I work at either place. And they're the variables that affect how much I get paid in a week period, depending on how more or less I work or which type of job I work. All right, so there's my variables. All right, now let's go through and start looking at some details here. I can work a maximum of 30 hours per week, which means I could work 20, 28, 29, 3. I just can work no more than 30 hours. So something is going to combine to make an inequality. Maximum means it could equal 30, but it has to be less than or equal to 30 hours. All right. And then I also need to make $280 in order to cover my expenses. So that $280, well, I have to at least equal that. But you know, we all like to make more money. So my inequality is the amount of money I make has to be greater than or equal to $280. All right, I got to keep track of my office job pay. It's $14 an hour. So for every hour, which is represented by X, number of hours, it's $14 times X number of hours is going to tell me how much I make that week at my office job. And my babysitting job only pays 10 bucks an hour. So for all the hours Y I spend babysitting, it's $10 times each of those hours. All right, I think we got our pieces together. We're kind of doing some translating here. Let's put together my inequality now, my linear system. I know that I can work a maximum of 30 hours a week, which means X, the number of hours at the office, plus Y, the number of hours babysitting. The hours at the office and hours of babysitting have to combine to be less than or equal to 30. So my first inequality is going to be X plus Y has to be less than or equal to 30. That's taking this scenario, my variables, and just saying, essentially, I have to work less than or equal to 30 hours in a week. That's the most I can do. So I'm going to combine my hours from babysitting, combine my hours from my office job. It's got to total at least less than 30 or equal to 30. Okay, the other one is how much money I make. So the money I make from my office job plus the money I make from my babysitting job Well, I want that to be greater than or equal to $280. So there we go. We've now got a system of inequalities that expresses what is going on. So again, hopefully this all makes sense. As you're doing stuff, as you're using algebra to solve word problems, every letter, every symbol should make sense, should have some sort of meaning as we're putting it together. And again, that's why defining your variables is so important. It helps you give that meaning into the problem. Okay, so there's my inequality. I'm going to go ahead and I've already got the graph made up. I like using the Desmos graphing calculator. It's a free online one. And I'm going to go ahead and paste it in here for you guys to see. Okay, so there is the graph showing of this linear system of inequalities right here. So the first graph, the one up top here, that represents the blue shaded area. The second graph represents the red shaded area, and you can see where they overlap is this purple section right here. So this purple section represents the solution set to both of these inequalities, or the solution is to the system. So let's think about what we have here then. Any point inside that purple area is going to be a solution. So let's try it out here. I'm going to pick this point right here. It's kind of right in the middle. So the way this is broken down, each square represents 2.5. So that's 10, 12.5, 15, 17.5, and 20. So the coordinates of this point based on the graph are an x value of 12.5 and a y value of 15. So what that particular point is saying is work 12.5 hours at the office and then work 15 hours babysitting, because that's what my x and y values were defined as. And if I work those hours, then I'll have worked less than 30 hours, which makes sense. 15 plus 12.5 is 27.5 total hours. But I'll have made enough money to meet my weekly expenses. So let's just check that part. I'm curious to see that out. So I know that they are definitely less than 30 hours. So that meets that inequality. So let's test it out. Does $14 times 12.5 hours at the office plus $10 times $15 or 15 hours of babysitting, let's see what that actually equals here. So 14 times 12.5 is $175. So I'm going to make $175 at the office, and 10 times 15, I'm going to make $150 from babysitting. Together, that's going to be $325, which definitely is more than the $280 I need. All right, so I'm feeling good. We just checked it out. That is a possible solution. And any point in this region, you can see there's an infinite number of combinations of hours, are all possible solutions. But now let's go back. I want to find, in this particular question, I was asked to find what is the least possible number of hours you can work at your office job and still meet the requirements. Okay, so for that, the office job was my x variable, so I need to look along my x-axis right here. And I want to find the least amount of hours in the solution set that'll still meet it. Okay, so it may look like this point right here would be the least, right? But that's just saying you can work 20 hours at the office and no hours at babysitting, and you can still meet what you want. But I want to find, well, what's the least possible hours at the office job. So let's keep following the purple area. I want to find the purple area with the point with the smallest x value. And it actually looks like right here in the solution set, there's a couple of them, right? It looks like I could work maybe 18 hours babysitting and still meet what I need. Oh wait, no, 20, 22, 25. That'd be 28. That's a 30 right there. So it looks like I could work 28 hours, 29 hours, 30 hours. It looks like I could do all babysitting and meet what I need, which makes sense, right? So if I put, let's take my inequality. If I work 0 hours babysitting, sorry, 0 hours at the office, I'm gonna put 0 in for X, that leaves just $10 an hour working babysitting hours to make at least $280. Well, if I make Y, if I work 28 hours, or if I work 29 hours, or if I work 30 hours, those will all multiplied by 10 will get me what I need. So theoretically, I could just do babysitting all week and make what I need. The office job might be a little bit nicer because it pays a little bit better. But there we go. The least possible number of hours at my office job, I can work 0 hours at the office and still make my minimum amount. Still meet minimum goal financially. All right. So there we go. Hopefully that's a helpful scenario, a helpful word problem in terms of taking a situation that involves a couple of different inequalities, using an inequality or writing inequality from the problem, representing the inequality with a nice little graph, and then using your graph to help determine which solution are we trying to find. Again, there's a lot of different solutions, but then we particularly found the ones that were the problem was asking me to find.